Hello, welcome to 14.2, day 1. Here are your notes and examples. Here's your problem of the day. So we are going to get to our drawing here. All right, so remember if you see parentheses, so we got to solve for x. So we're going to split our problem down the middle, and we need to solve for x. But first we got to distribute this 3. When you see parentheses, you got to do distributive property, and you got to get rid of this 3 because you're not going to be able to solve it without doing it. This side does not have parentheses, so we don't need to do that to this side. So we're going to focus over here. So I'm going to take that 3 and do 3 times 2x. 3 times 2x gets us 6x. And 3 times 1 gets us 3. It's a positive 1, positive 3, so it's going to be a positive 3. And then we're just going to bring all this other stuff down on the other side. 2x plus 7. Okay, now we got to get the x's to one side, the constants to the other side, and get x all by itself. So we're going to make a 0 pair with the smaller variable. Is 6 smaller or is 2 smaller? 2 is smaller, so we're going to make a 0 pair with 2. So I have a positive 2x. Opposite of positive 2x is a negative 2x. So I'm going to do that to both sides, minus 2x. These go away. I have 6x minus 2x gets me 4x plus 3 equals 7. Okay, now I got to get rid of this 3 over here. So I'm going to make a 0 pair. So I'm going to need a negative 3. Cancel out. Negative 3. Left with 4x equals 7 minus 3 is 4. Look at that. This is going to work out nice. So we're going to divide by 4 because that's 4. The 4 and the x are held together by multiplication. The opposite of multiplication is division. I'm going to divide by 4. That turns into a 1. And so does this. This turns into a 1. So now we get x equals 1. Final answer. Take this time to solve this one on your own on Nearpod. So check back in a minute when you are done. Pause here. Okay, you had a similar problem to do. You should have split your problem down the middle. And we have parentheses on this left side like I did. And so we are going to distribute that 4 to 3. 4 times 3 gets us 12 x's. And 4 times 2, those are positive numbers. So we got 4 times 2 is 8. Bring down the right side because we didn't touch anything. Plus 12. Okay, so now let's get the variables to one side. I need to make a 0 pair with the smaller one. Which one was smaller? 12 or 10? 10. So we are going to make a 0 pair. So it's a positive 10, so I need is negative 10x. Those go away. Minus 10x. And so we have 12 minus 10 gets us 2x. Bring everything else down. Plus 8 equals 12. Now I need to get rid of this 8. So I need to do the opposite of positive 8, which is a negative 8. Negative 8. Those go away. So we got 2x equals 12 minus 8 is 4. Ooh, this is super nice. Oops, I just moved the 4. And something weird happened. Okay. 4. Then we're going to divide by 2. Divide by 2. 2's go away. X equals 4 divided by 2 is, you got it, 2. Okay, hopefully you're working on this skill for high school. Here we go. We are going to work on today's stuff. It's basically very similar to last week. We are going to be constructing trend lines and write an equation. All right, scratch that. We're not going to be doing an equation just yet. That'll be for our next class. We are going to just be drawing a line of best fit. We are going to identify the relationship between the two axes, and then we're going to interpret the relationship, and we're going to make a prediction. So I'll kind of mention some pieces to help prepare you for writing equations for next class. But let's talk about line of best fit. So here's our example. A line of best fit is a line that goes through as many dots as possible. Now, when I say that, it doesn't mean you do this. This is not a line of best fit. We're not playing connect the dots. That's not what a line. What does a line mean? A line is a straight line. It goes straight, right? So we're going to try to go through as many dots as we can. Now, a ruler would be really handy right now. I don't believe Word has one. But I think, I don't remember. Watch, I'll figure it out later. Yeah, oh well. Okay, so I'm just gonna hand draw these. So ideally we would have a ruler, and a really cool one to be a cool, like a clear ruler, but I'm gonna look and see how many dots can I make in a line. And I kind of see, and we wanna have dots on our line. So I kind of see that is a pretty good line that has the most dots on it. And you kind of like, a line of best fit is kind of like in the middle of all the dots. Like kind of like where the average goes, but you also want the most dots on your line. So that's kind of where we are. Now, since we're hand drawing these lines, it's gonna be a little harder to, like, you kind of got to round. So if we had a straight ruler, I'm assuming this line would go through 75 down here, right? Because it's not going to go through 0. That's like way too far off. But I'm assuming it's going to go through 75. If you recall, so here's where I'm going to remind you about writing equations on a graph. Remember, our equations look like y equals mx plus b. Remember, you're not doing this today. This is a reminder, prepping you for tomorrow. B is the y-intercept. So that is where the line goes through the y-axis. Where does this line go through the y-axis? 75. You are correct. So this is the line would start at 75. I know mine is not that straight and it didn't go through there, but we're going to round get close. So 75. So in my equation, this would be 75. And now x would always stay there, and then next we'd find m, and m is slope. And all we will be doing is taking 2 points on our line, so maybe some two nice ones. So I would probably take, again, I'm not going to go through all of this, but I'd take this one and this one, because they're both on my line and they're both on nice intersections, like both crosshairs. You see that? So because I'm not going to pick this one, it's floating in the middle, and I don't know exactly what number that is. But if we take these two, we have definite numbers, and we're going to do the slope formula where you take the ordered pairs and you do y minus y, remember y2 minus y1 over x2 minus x1, and we get a fraction to put here. So that's for tomorrow, but that's what we're kind of going for. But today we're working for the line best fit, so I did that. Now we're going to identify a relationship as a positive, negative, or no association. So this is a reminder from last week. Does my line go up? Does it go up? Does it go down? Or was it too scattered for me to even draw a line? You guessed it. It is a positive relationship. It goes in an upwards direction. Good job. Next, we're going to interpret the relationship. So let's look at what we're talking about here. What the heck are we talking about? I see visitors, and I see average daily temperatures, and the title is beach visitors. So we're talking about a beach. We're talking about people who go to the beach, and it looks like, so it's going up. So there's a positive relation. So the higher the temperature, the more visitors that go. Do you agree with that? As the temperature goes up, the visitors go up. Okay. And then, so that's our interpretation so it's a positive interaction. And as the temperatures get higher, there's more people that go to the beach, right? You want to go to the beach when it's hot. Last, make a prediction about the number of visitors to the beach when the temperature is 90 degrees. So 90 degrees, these are going by what? We got 80 to 84, so 80, 82, 84, 86, 88, 90. So this is 90 degrees. So what is our prediction for when the temperature is 90? How many people do you think are going to be there? Let's take a guess. So here's 90. If I go boop, 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 boop. Here, so we got it's between 375 and 450. So what is that going to be? Like, that's 25, 50, some difference. So that's 75 between each one. So half of 75 is what? 75 divided by 2. 37.5. Okay, we don't have to get this specific, but it's probably going to be, let's see, 375. Okay, what's 375 and 450? What's halfway in between there? So I did 75 divided by 2, so 37.5, I'm going to add to 337 plus 303, sorry, 75. Oh my goodness. 375. 412. So roughly 412 people. So the distance between 450 and 375 is 75 people. I cut it in half because I think my line is like right in half. So when I took the half, I then took 375 and added what half of this space was, which was at 37.5. So about 412 people. And so I'd write 412. 412 people. Okay, so that's probably the longest example I'm going to give. I'm just going to go through the line of best fit and go quicker through some two other ones that I believe are on your Nearpod. So from here, please go continue to Nearpod. If you'd like some extra help, please continue to watch me. So I'm going to look at this picture and I see, so we got experiment results, the amount of sunlight, and number of bacteria. So a line of best fit. Remember, I need to make a line that goes through as many dots as possible. So I'm going to try to go probably through here and go. And remember, try to make it as straight as you can. I know we're drawing, it's kind of hard. Mine kind of bends a little bit. Try not to make it bend. But basically, it's probably going to start up here at 16 and it decreases. It's going down. You see how it's going down from left to right? It's going downhill. It's going downhill, so it's a negative correlation. Our line of best fit, and so we are able to draw a line that goes through a majority of the dots. It probably could even go lower, maybe, and get through these dots. So we do have a negative, and so it looks like as the amount of sunlight goes down, the number of bacteria goes up. Ooh. See, as the sun goes down, bacteria is going up. Isn't that interesting? So maybe a good interpretation is sunlight kills bacteria. So if there's no sunlight, that's how bacteria and like mold and stuff begins. But if it's in the sun kills it, and there's not very much bacteria. Super cool. Okay, so I did all those. All right, here's my last example, super quick. So we have an exam score and shoe size. So this was a thing that they did, and do you see how the dots are everywhere? They're literally everywhere. Can I make a line that goes through all the dots? And like, can you see a pattern? Do you see a pattern either going up or down? I can't see one. Because even if I drew it like this, there's still dots everywhere. They're very spread out. It's not gonna, so because the dots are all spread out and I can't draw a line that will go through like all of them equally, I mean, I guess you can defend it and say it kind of goes like this, but it's still like, it's just a scattered amount of dots. They're not all nice and condensed like this one. So the closer the dots are together to a line, the more, what's the word I'm looking for? The closer the dots are together, the more accurate, I would say, the hypothesis is. So right now they're trying to compare exam scores and shoe size. So if the dots are really close to one line going the one side, that means that exam scores and shoe size have an impact on one another. So maybe if you have a smaller shoe size, you get better scores. But since shoe size does not affect your exam score. That's why all the dots are everywhere. So that's why it doesn't really work out. But when the dots are super close and they follow a trend line, that means that it's more likely that it's like it actually works. So this tells you that yes, the more sunlight you have, the less bacteria you have. So it kind of shows. And same with temperature. So when there's no line of best fit, dots are everywhere. That means there's no relationship, no association, and so there's no correlation between shoe size and exam scores. You can have any size shoe you want, and it does not affect your exam score. So there you go. There's all three. Let us know if you have questions.